Today I'm going to discuss an algorithm called iterative merge sort or non-recursive merge sort. Iterative merge sort is an algorithm which divides the array into smaller subarrays, sorts them individually, and then merge them to achieve a fully sorted array. In this example, we will see the steps of making iterative merge sort. First of all, we start by splitting the array into smaller subarrays. Each element here is as an individual subarray. After splitting the array into subarrays, we start by taking each two subarrays individually. Then we start sorting the two subarrays to make a new array which is sorted by merging them. We repeat these steps to get a new array with larger elements. After repeating these steps, we will get finally the fully sorted array. Now, to sum up in the analysis section, we have two phases, divide phase and merge phase. In the divide phase, we start by dividing the array into halves. The number of iterations needed to completely divide the array is big O of log n, where n is the number of elements in the array. This is because in each iteration, the array size is halved. The second phase is merge phase. In each iteration, pairs of adjacent subarrays are merged. The merging process takes linear time, which is big O of n, where n is the number of elements in the array. Since there are big O log n iterations in total, the total time complexity for merging is big O n log n, and this will lead us to have a time complexity big O of n log n. And this came from the divide phase and the merge phase together, the big O log n and the big O of n log n. After making the two phases together, we will have a big O of log n plus big O of n log n. But we only take the larger number of them, which is big O of n log n. And this is the code section. In this section, we have firstly the merge sort function. This function has subarray size, which initialize the size of the subarrays to be merged. We have two while loops. The outer loop is to continue until the size of the subarrays becomes equal to or greater than the length of the input array. The inner loop iterates through the array. Determine subarrays by mid, right, and left. The mid and right determine the boundaries of the subarrays to be merged. These boundaries are based on the current left index and the subarray size. We have merge operation. Merge operation, we called it to merge the determined subarrays. And here, the update pointer left plus equal to multiply subarray size updates the left pointer for the next iteration of the inner loop. And this subarray size multiply equal to doubles the size of the subarray for the next iteration of the outer loop. The second function called merge. In this function, we have n1 and n2. These represent the sizes of the two subarrays to be merged. We create temporary arrays called L and R to hold the elements of the left and right subarrays. The elements from the original array are copied to the temporary arrays L and R in these two for loops. In the merge process in the while loop, it compares elements from the two subarrays L and R and merge them back into the original array in sorted order. If the element from L is smaller or equal, it's placed in the array and the index I for L is incremented. If the element from R is smaller, it's placed in the array and the index J for R is incremented. The index K keeps track of the position in the original array. Here, we are copying the remaining elements from the temporary array L and R into the original array if there are any. This function, sort button clicked, is for showing the results and the process in the GUI. And this is some labels and text boxes for the GUI implementation. And now let's try our algorithm. As we can see, the original array is 647281. The first step is making the sort and merge for only the first two elements, which is 4 and 6, by making all the elements as subarrays and start sorting them. The second step is sorting the second two elements, or the second two subarrays, repeating this process until we reach the final two elements and sort them. After sorting them, we will have the final result, or the final array, which is sorted.